Hello everyone! Welcome to another video lesson brought to you by Grade 7 Mathematics teachers of Camarines National High School. My name is Teacher Donna Geronimo and I will be your teacher for this video lesson. Are you ready? Let's start! I want you to meet Teacher Debbie. Teacher Debbie wants us to get the sum, the difference, the product, and the quotient of the integers 9 and 3. She also wants us to identify if the given answers will also be integers. Teacher Debbie will give us 10 seconds to answer this one. So let us get our scratch papers, pencil, or ball pen, and let's get ready. I hope you are now ready to get the sum, the difference, the product, and the quotient of the integers 9 and 3. Your timer starts now. Time's up. Now let us find out if you are correct. Let us start with the sum of 9 and 3. If your answer is 12, you are correct. Now let us have their difference. If your answer is 6, you are again correct. Now let us have their product, and their product is 27, and their quotient is 3. So if your answers are 12, 6, 27, and 3, good job! And all of our answers are called integers. Now this time, Teacher Debbie wants us to get the sum, the difference, the product, and the quotient of the integers 2 and 5, and also identify again if the given answers are integers. So again, you will be given 20 seconds to answer. Your timer starts now. Time's up. Now let us find out the correct answers. Let us start with the sum of 2 and 5. If your answer is 7, you are correct. If your answer for their difference is -3, you are again correct. If your answer for their product is 10, you are correct. And if your answer for their quotient is 2/5, you are again correct. Now if you notice, 7, -3, and 10 are all integers, while 2/5 is not an integer. So what do we call this number? In this video lesson, we are going to talk about these numbers, and these numbers are called rational numbers. For this video lesson, our learning objectives are to define and describe a rational number. Also, identify if a given number is rational or irrational. So let us first define rational numbers. The word rational comes from the word ratio. So it is a number which can be expressed as a ratio or in the form P over Q, where P and Q are integers and Q is not equal to 0. Now let us have examples. I have here 1/5, 3/8, -3/14, and 5/11. If you notice, all of these numbers are in the form of P over Q, where both P and Q are integers, and Q is not equal to 0. Therefore, the given examples are rational numbers. If you notice, these numbers are also familiar to us already. We call these numbers as fractions, where the upper part number is called the numerator and the lower part number is called the denominator. Therefore, fractions are examples of rational numbers. Let me give you another example. I have here 0.5, 1.2, and negative 3.7. If you notice, these numbers are also familiar to us. We call these numbers as decimals, and decimal numbers can be expressed as fractions or in the form of p over q, where both p and q are integers and q is not equal to 0. Therefore, decimals are examples of rational numbers. In dealing with rational numbers, there are a couple of things to remember. First is that every natural number is a rational number, but a rational number need not be a natural number. Remember that natural numbers are also known as counting numbers. So if we have 2 as an example, we can express it as 2 over 1. In other words, every natural number n can be written as n equals n over 1. Therefore, all natural numbers or counting numbers can be expressed as p over q, where your p is your natural number and q is always equal to 1. Next is that 0 is a rational number. Therefore, we can express 0 as 0 over 1, or if we have 0 over 1, 0 over negative 1, negative 0 over 2, these are all examples of rational numbers. In other words, 0 is equal to 0 over b, where b is any non-zero integer. Another thing to remember is that every integer is a rational number, but a rational number need not be an integer. So if we have negative 1, it can be expressed as negative 1 over 1. Or if we have negative 2, it can be expressed as negative 2 over 1. In other words, any integer a can be written as a equals a over 1. Another thing to remember is that every fraction is a rational number, but a rational number need not be a fraction. So for example, if we have a over b as your fraction, where a is the numerator and b is the denominator, therefore a and b are integers. So we have a fraction where a over b is the quotient of two integers, such that b is not equal to 0. Now let us have an activity where you need to identify which among these numbers is not an example of a rational number. I will give you 20 seconds to answer this one. Your timer starts now. Time's up. The correct answer is 9 over 0. If your answer is this one, good job! If you remember, a rational number is in the form of p over q, where your q should not be equal to 0. Now I want you to meet Anna. Anna wants you to look at these numbers. She wants to know if these numbers can be examples of rational numbers. To answer Anna's question, Teacher Debbie will give us additional things to remember. We mentioned a while ago that decimals are examples of rational numbers, but we have to remember that not all decimal numbers are rational numbers. Decimals that are terminating and both non-terminating and repeating are the only ones considered to be rational numbers. Now, to understand this better, we have to define terminating, non-terminating, repeating, and non-repeating decimals. Let us start with terminating decimal. It is a decimal number that has digits that end. Examples are 1.5, 0.2, and 5.1. While non-terminating decimal has digits that go on forever. It means that we have infinite number of digits. It can be repeating or it can be non-repeating. We should also remember that non-terminating decimal will make use of the symbol we commonly known as ... or ellipsis, or the horizontal bar notation symbol mathematically known as vinculum to indicate that the digits go on forever. Non-terminating repeating decimal has a digit or a block of digits that repeat over and over again without ever ending. Unlike a non-terminating, non-repeating decimal, which continues on and on but does not have a repeating pattern of digits. Therefore, decimals of this type cannot be expressed as fractions and are considered to be irrational numbers. Now let us look at the given examples. Another thing that we should remember is that a radical expression with a perfect square radicand is a rational number. In this given example, 4 is the radicand, and having its square root taken. Now, a perfect square is the square of a rational number, or a product of a rational number multiplied by itself. Let us look at the given examples. If you notice, 4 is a perfect square. Therefore, the given example, which is the square root of 4, is a rational number. I have here another example, the square root of 5. If you notice, 5 is not a perfect square. Therefore, the given example is not a rational number. Another thing that we should remember is that there are numbers that cannot be expressed as a fraction or cannot be written as the ratio of two integers. We have mentioned a while ago that these numbers are considered to be irrational numbers. An example of an irrational number are radical expressions that do not have a perfect square radicand, like the square root of 5, the square root of 6, and the square root of 17. Another example of an irrational number that we have mentioned a while ago is a decimal number that is both non-terminating and non-repeating. Now let us have another practice activity. So let us prepare our scratch papers, ball pen, or pencil to answer this one. You are going to write R if the given number is rational and IR if it's irrational. You will be given 1 minute to answer this one. Your timer starts now. Time's up! Now let us check your answers. If your answer for number 1 until number 9 is letter R, you are correct. Now for number 10 and number 11, the correct answer is IR. And for number 12 and 13, the correct answer is R. For number 14, IR, and for number 15, R. If you got this all correct, good job! I hope you were able to achieve the learning objectives that we had mentioned a while ago, and that is to define and describe a rational number. Also, identify if a given number is rational or irrational. Hope you learned a lot from this video lesson, and please do not forget to watch the next video, which is all about addition and subtraction of rational numbers. Again, this is Teacher Donaline Geronimo, or Teacher G for short. Have fun learning mathematics.